What's up, YouTube? My name is Johnny Bannon with Trepid Technologies. And today, we're going to be going over VTP, guys, a protocol that gets absolutely no love from Cisco. As you can see, I got my little helper here, so hopefully she can help us get through this video. Sorry for the squeaking, hold on. Alright, guys, now let's do some VTP. Alright, guys, so let's click that link below. Let's bring up my Confluence page. So here we have a pretty robust how-to on VTP. So this goes over its versions, what VTP is, and what it does, and why it was made. So VTP stands for the VLAN Trunking Protocol, right? But it actually has nothing to do with creating trunks. It has everything to do with creating and streamlining or automating the VLAN process. And remember, this is a Cisco proprietary technology, right? So they made this in the hopes that it would take off and become a standard. But I've actually never seen this in use in any live network that I've been on. So we come back here, right? We see it has 4 modes. Transparent, server, client, and off. And during our how-to, I'll go over all 4. I have 4 switches, and each one will be in a different mode. Some basics about VTP, right? There's 3 versions. This one's going to do version 1 and 2. VTP is sent on the native VLAN, and it sends VTP configuration messages to its neighbors. These messages are going to contain VTP information, right? So if they need to make a change, what the domain is, the mode of operation of the originating packet, right? So if switch 1 is client, its VTP message is going to say that it's a client. And then there's multiple different configuration options, so you can make a domain name if you want. You can leave the default. You can make a password, so you can set up authentication. And you can actually reset your revision number on the VTP server. So this is important because that revision number, right, is actually who chooses who's the main VTP server. Okay? And if any of these options are different, VTP will not work, okay? Another little thing, VTP version 1 or 2 only does standard range VLANs. So just 1 to 1005. And they only send packets on trunk links. So that might be where the trunking protocol came from. But I just want to let you know this has nothing to do with the forming your trunks, okay? But access links will not give VTP messages. Okay, guys, so the 4 modes you need to know. Transparent. So this mode, a switch will not make changes based on the VTP packet. It'll just pass those VTP messages on to its neighbors. So that means the VLAN database will not be created from a VTP server anywhere, right? Because remember, VTP was originally made to streamline and automate the creation of VLANs on your network. The VTP server mode is the one that will create the VLANs and tell the other switches to have the same VLAN database as it. So all switches can be in this mode, and then the one with the highest revision number is the server that actually goes and makes all the changes for the network. You can be set to client. So when it's in client mode, you cannot make VLANs locally. You can only receive and pass on VTP packets. So it gets its VLAN configuration from the VTP server. And then off means that VTP will be completely disabled on the switch. And I'm not sure if it'll pass on VTP messages. We can actually test it out in our network environment. So first, we're going to bring up our GNS3 environment. Go to my projects library, CCIE Switching Lab. I got to re-add this link because if you watched my previous video on trunking, I deleted it. Let's turn on all these bad boys, zoom in for you guys. Let's get started on some configuration. So I'm going to bring this over to the left. So you guys won't be able to see this, but I actually have my Confluence page up on the left, and I'm going to follow it to do all my configuration. So I'm going to console into all my switches. So the best thing to do for this lab, guys, if you're just watching, is to have the network diagram up on another screen and then reference it as I make these changes. before we start, I am going to just verify everything. So I'm going to change the host name. This is switch 1. Switch 2, do the same thing. Switch 2. So I'm just going to do a show run real quick. I'm going to run through these and see if anything's configured. Nope. We'll do this on switch 4. Show run. So we have some configuration on there. So what I'll do show IP interface brief. I'm going to default everything. So default. And this will, like the command says, will bring everything back to its default. 3, gig 1/0 through 3, gig 2/0 through 3. Yeah, these viral switches are a little weird. This is how their interfaces are. We just gotta deal with it, right? Kind of annoying, not like a regular switch. I'm gonna go in here and turn this off real quick. Should probably do this on all my switches. So if you want to skip ahead, guys, please go ahead till we actually get to the VTP config. Because right now you're just seeing me do some basic stuff. So port consistency, do show run. You should not be configured or anything. So why would we get that spanning tree message? I'm not sure. Okay, guys. Volume 0. Volume synchronous. Awesome. So guys, in these videos, they're not scripted. So I'm just going straight off my Confluence page, like I expect people to follow my blog to do. So that's why I do it this way. Since you guys know, I know how to configure trunks if you watch my previous videos, I'm just going to copy and paste straight from my Confluence how-to page. Alright, so I'm going to make sure that I configured, I don't know why this has switch on it too, same one, again these viral switches are not perfect by any means, guys. So right now I'm just configuring the trunks for all these neighbors. I'm literally just copy and pasting from my code snippet that I made in the Confluence how-to page. Now, if I want to do my due diligence, right, I would make sure that these interfaces I'm configuring are legit and that they're actually my connections to the neighbors. See, CDP not being enabled on here is crazy. You can do this, CDP enable. You can do that on all these just to make sure. CDP enable. I have to do it at this level too, from global config level. CDP enable, so we'll do that as well. CDP run at the global config level. CDP enable at the interface level. CDP enable. CDP run. Alright, so hopefully CDP is on now. And so what we're going to do at switch 1 is we're actually going to make this our server. So our switch 1 will be our VTP server. So it says it already is, okay. And then we're actually going to set the domain name so I can show you guys. So the default is null. And if you see these other messages, it's saying there's an error, right? Mismatch. So we're going to have to set these on switch 2 because our switch 3 is just going to be our transparent switch. So I'm going to make a password, Cisco, and then we're going to make this our client. So VTP mode client, VTP domain. It has to be the same name. That's why we got that mismatch right there. And then of course the password as well. Alright, this will be VTP mode transparent, so we don't need to do any of that other configuration. And this one's just going to be mode off. Alright. So now let's do some verification. So the command we're going to do here is show VTP status. So let's do this on all these switches. We can see it's a server. We can see the version running is just 1 because we didn't set the version to 2, so now it's at its default. We can see the domain name, device ID, and we should be able to see the revision number right there. Do the same thing on here, show VTP status. We can see client. See MD5 digest checks on this mass on trunk. Something else. So let's see. Show CDP neighbors. Gig 2/0 detail. Switch 1. Let's actually look at our diagram. That probably should not be there because we have the same password configured. We'll just go along and see. Might just do a reload on these switch guys. Let's just keep going through our how-to and see what we get. So we get 1011. Again, that's the ports going to switch 1. Even though we can see that it's the same, and this is transparent mode, so there shouldn't be an issue. This should just be passing along. Let's see what we get on here. It's off, so we don't get any error messages. Alright, now just following along with our how-to, let's change the version to version 2, VTP version 2. VTP version 2. Okay, do show VTP status, why we can't change its version. So it says it is version 2. So even though it didn't accept our command, it's still version 2 because it took our configuration from our VTP server. So the VTP server over here updated this. Make this version 2. Awesome. So now we're going to create some VLANs on switch 1, and we're going to see where they propagate throughout our network. VLAN 50 through 60. Exit. Now let's see. Show VLAN brief. We got all those VLANs, guys. Do show VLAN brief. So these are the same, right? Because these are participating in VTP. Now we look at switch 3, show VLAN brief. It doesn't even care, right? Even though it's accepting those VTP messages, it's not doing anything with them. Show VLAN brief, and this should just be whatever locally it has created. So we can see that VLAN or switch 1 and 2 are synced. Now if we go to switch 2, right, let's try to create a VLAN. VLAN 49. It's going to give us an error. So remember, the clients cannot actually create VLANs. So now what we're going to test, right, is to see if we can actually ping between all these switches, even though switch 3 and 4 are not participating in VTP. Okay? So we're going to make VLAN 22 on all of them. So just doing it on switch 1 will make it on switch 2. We'll come here, VLAN 22. VLAN 22 is already made. I had some foresight there, look at that. And now before we start, let's do show interface trunk on all these. Looks like we're trunking to all of our neighbors, right? Don't know why it's missing 22 right there, 22 right there. Show run interface gig 3/2. Show VLAN brief. We made VLAN 22 on there. Alright, so it's too easy though, guys. We're still going to make our SVI for VLAN 22. The commands are like this. We're going to make SVI VLAN 22 for all of our switches, and then we'll make a TCL script. And we'll ping all of our switches. And we'll see if that we can have communication even though we're not all participating in VTP. So we'll do this TCL script. We can see VLAN22 came up on all these. We'll do this from switch 1. Type in for each address. Alright, and the address is our variable name, guys. So that's what, just some little knowledge for you. This could be anything, right? This could be named my name, for instance. We just got to make sure that when we call that variable, we use that same name. So we're just going to put in the addresses here, do ourself, switch 2, 3. This is just a simple script to ping, right? It's called a TCL script. Now the action we're going to do on all these variables is ping. So our variable name is Johnny, right? We're going to close up that bracket, hit enter, we're going to ping all 3. So we can ping switch 2, little ARP delay. We can ping switch 3, switch 4 is not coming up. Let's see what the issue is there, guys. Show interface trunk. Looks like the VLAN's allowed. Do show interface brief. It's up and up. Let's check on switch 1. We'll get out of that TCL script. Show interface trunk. Sorry about that. Our connections are still good. Alright, let's see. Let's go in and just... Why are all these status resets? Let's go in and just close down all of our interfaces, guys. We'll flap them, as people like to say. So let's get into all of our trunks. Shut. No shut. We'll show IP interface brief. Make sure we're all up again. We'll see where we can ping from here. See if we can ping other neighbors. Just super slow. I guess we're getting some. We got one right there. Let's try that one more time. This might be a spanning tree issue. Okay. Very under minutes. Let's do show spanning tree VLAN 22. So the root is gig 2. Show CDP neighbors. Gig 02. Detail. Who is that? Switch 1. So we should be sending all VLAN traffic to switch 1. To show spanning tree VLAN 22. Here's what we're going to do. Spanning tree VLAN 22. Priority 0. So we're going to go straight to switch 1. So there should be some reconversions on there. Let's see if we can ping. Don't quote me on this. It might have been a spanning tree issue. Yeah, that's what I did, right? Make sure I'm doing this TCL script right. Need a space. Come on now. .1, 22.1.2, 22.1.3. Close that up. We'll do ping. Call that variable address. These are all the variables we put in to address, right? Close it. Let's do our pings. And still can't get to switch 3. Well, let's try that TCL script over here, guys. So now we can't ping switch 3. I still think we're probably having a spanning tree loop. Show spanning tree 22. Show CDP neighbors, gig 1/0. Let's go into switch 1. Do show spanning tree VLAN 22. There should be no issues. Do show CDP neighbors gig 2/0. Switch 1. So all traffic should be going to switch 1 on VLAN 22. Excuse me, guys. Sorry for this video being so interruptive. So we did everything right, guys. We got everything configured correctly. For some reason, one ping isn't working between these switches, and that's okay. Again, we set everything up correctly. Sometimes these labs just do that. I'm going to continue troubleshooting. But for now, I want to thank you guys for viewing. And remember to keep learning every single day. Thank you.